Hi everyone, this is video number 15 of the Regents Chemistry curriculum, and our topic for today is acids and bases. We're going to talk about acids and bases, we're going to talk about indicators, and we're going to talk about titration. We're going to try to get all this done in less than 30 minutes. So by the end of this video, you're going to be able to use different indicators to determine the pH of a solution and use that information to calculate the H+ ion concentration. Next, you're also going to be able to perform a titration reaction or learn how to perform a titration reaction and calculate the concentration of an acid or a base. Okay, with that said, let's get started. Here are a bunch of questions. Please read the following statements, determine whether they are true or false. Pause the video, read carefully, and let's get started. All right, here we have them. Properties of acids and bases. So you can read over this. Acids are all going to come from table K. Here's table K to show you what the acids are. I just pass it. There we go. So notice all of the acids are going to start with an H. See, they all begin with H's. Even ethanoic acid actually begins with an H. Sometimes it's written like this. Don't get tricked by that. Still an acid. It's an organic acid. This is really just vinegar, by the way. Vinegar, the one that you put on salad. This carbonic acid is present in soda. And then you have sulfuric acid, you have nitric acid, nitrous acid, hydrochloric acid, very common acid. Okay, and you also have a list of bases here. Bases tend to be very alkaline. Notice all the bases here end in OH, with the exception of NH3. Okay. Here are their names: sodium hydroxide, potassium hydroxide, calcium hydroxide, and you have aqueous ammonia. Aqueous means dissolved in water. Okay, so let's go back. Acids have high concentrations of H+ ions. Obviously, they all began with an H, so they have a very high concentration of H+ ions. And since they have a lot of H+ ions, they're going to donate them. So acids donate. So here's Bahad. Bases accept the H's. Acids donate them. Acids pH on a pH scale. The pH scale goes from 0 to 14, and 7 is the neutral point. So pH stands for potential of hydrogen. So on a pH scale, anything below 7 is considered acidic, and anything above 7 is considered alkaline, also known as basic. Okay. Acids are electrolytes, which means they're going to conduct electricity. Acids react with metals, and if they're going to react with a metal that's more active than a hydrogen, that metal is going to replace the hydrogen. Here's an example. Zinc is more active than hydrogen in hydrochloric acid. So this zinc will knock off the hydrogen and take its place. So the zinc will now hang out with the Cl, and the hydrogen will come right off. So hydrogen gas is very flammable. How do you know which metals are more active than the others? Simply just look at table J. Here we have table J, and it shows the metals that are more active. So more active is on top. So here's hydrogen. If you go anywhere on top of that, you're going to get a more active metal. Okay, sometimes you get non-metals that can react and with acids and replace the non-metals that are in the acid. For example, an HCl, if you react that with fluorine, the fluorine will come and knock off chlorine. Chlorine will come right off. You're going to get chlorine gas in the air, and then fluorine will bond with hydrogen to get hydrofluoric acid. Okay. going back to here. Here are some common examples of acids: vinegar, coffee, carbon dioxide, wine, citrus fruits. Acids tend to be very sour. Okay. Bases, they're all on table L. Obviously, they have a lot of OHs, so they're going to donate the OHs and accept the H's from the acids. On a pH scale, we said that 7 was here and 0 and 14 was here. So bases would be all the way down here. And bases are known for having a lot of OHs, so the concentration of OH tends to increase as you go in that direction, and the concentration of H, so here's where you have most acidic, so the concentration of the H plus ions or hydronium ions will increase as you go in this direction. So hydrogens increase this way, or hydronium ions increase that way, and hydroxide ions increase this way. Okay. At 0.7, the concentration of hydrogen ions and the concentration of OH ions are equal. All right. Bases generally have a pH that's greater than 7 and less than 14. They're also considered electrolytes. Let's just be careful and make a distinction between bases and alcohol. We know that bases end in OH, but bases are not alcohols. So many people may think of organic chemistry and may think that bases are alcohols because alcohols have an OH. Alcohols, the OH functional group for alcohols usually is attached to a carbon group. So you have a COH. Okay? So the OH again, when it's attached to a carbon group, you have an alcohol. For bases, let's go back to the bases table. You don't have a carbon. You have metals, sodium, potassium, calcium, or nonmetals like nitrogen, but you don't have a carbon. If you have a carbon, then you're going to end up with an alcohol. Okay. Also, we talked about NH3. NH3 does not end in OH, but it's still a base. Sometimes NH3 is actually written as H3N, which makes you think that it's acidic because it starts with an H, like all the acids, but be careful. Additionally, CH3COOH, this is an acid, not a base, even though it's written and ends in OH. CH3COOH is vinegar, and the official formula for it is right here. Examples of bases that are alkaline are green vegetables, broccoli, spinach, asparagus, all of these. Okay, so here's a quick summary of what I just said. All right, now let's talk about the relationship between the pH and the H. If the pH changes by 1, let's say you went from a pH of 5 to a pH of 6, the hydronium concentration is going to change by 10, or 10 folds in this case. So if I have a pH of 5, obviously I'm more acidic, so that means I have more H's than if I have a pH of 6. So the H concentration going this way is going to decrease. The hydronium ion concentration decreases in that direction. You changed by 1 pH unit, so therefore the hydronium ion concentration is going to change by 10 folds. Let's say you went from 5 to 9. Obviously that's 4 units, so I'm going to write 4 zeros, and I'm going to put the number 1 before that. That's how much the hydronium ion concentration decreases by. Same thing the other way. If the pH value changed from, let's say, 13 to 9. In this case, when the pH changes from 13 to 9, the hydronium ion concentration is going to increase because I'm becoming more acidic on the pH scale. So the hydronium ion concentration increases, and it increases by, in this case, from 13 to 9 is 4 zeros. So here's 1, 2, 3, 4, 4 units, 4 zeros, and just put a 1 before that. So it decreases by 10,000 folds, FOLDS. Okay. Here's another example, and here's the answer. All right. So here's more information about the relationship between pH and POH. So if you're calculating the pH, you'll take negative the log of the H plus concentration. If you're calculating the POH, negative the log of OH concentration. And same thing the other way. 10 to the negative pH is going to equal to the H concentration. And the pH plus the POH will always equal to 14. Therefore, if the pH is 7, then the POH is also going to be 7. 7 plus 7 gives you 14. We said that the neutral solution has a pH that's equal to the POH. And acids have a greater amount of H plus ions than OH negative ions. Okay. Moving on to titration. Titration is simply the process of adding an acid to a base in a double replacement reaction to produce salt and water. That's really all that titration is. Okay? So let's take, for example, HCl, acid, from table K. Add that to NaOH, a base, from table L. What's going to happen is that your hydrogen is going to combine with your hydroxide ions and is going to give me the HOH. And then what's left is that your sodium combines with your chlorine to give you your sodium chloride. Always write the metal first when you're writing an ionic compound formula. The metal always goes first. So sodium chloride. Okay? So titration is known as neutralization because when you add an acid and a base together, the H's will neutralize the OH's. So the positive H's will neutralize the negative OH's. So eventually the pH of the solution will be 7. You can identify the concentration of a solution using this titration formula. MAVA equals MBVB, and this formula is actually present on table T. So here's table T, the titration formula. MAVA equals MBVB, the molarity of the acid, multiplied by the volume of the acid, shall equal the molarity of the base multiplied by the volume of the base. Okay? So here's an example. If 3 milliliters of a 6 molar NaOH was used to neutralize 5 milliliters of an acid with an unknown concentration. So, what is the concentration of the acid? What do I know? My molarity of the base. So here's your MBVB, my molarity of, so let's just do it this way. My molarity of the base multiplied by my volume of the base, 6 is the molarity, volume is 3, so here it is, 6 times 3, equals the molarity of the acid, which is the unknown concentration, Ma, multiplied by the volume of the acid, which in this case is 5. When I do the calculations, I realize that the molarity of my acid is going to be 3.6 molar. This is a very highly concentrated acid and should be handled with care. There are several types of acids. There are monoprotic, diprotic, triprotic. And you should also be familiar with the acids that ionize completely in water. So these are very strong acids. You should be familiar with these. HCl, HBr, HI, H2SO4, HNO3, and HClO4. Okay, these are very strong acids and they ionize or dissociate completely in water. Sulfuric acid tends to ionize into 2 moles of hydrogen, making it a very strong acid than hydrochloric acid, which only ionizes into 1 mole. So sulfuric acid ionizes into 2 moles, and hydrochloric acid will only ionize into 1 mole. So this is even stronger than HCl. There are 9 strong bases you should also be familiar with, and these strong bases will ionize completely in water. So any group 1 metal, when combined with an OH, is going to give you a very strong base. And anytime you have calcium, barium, or strontium combining with OH, you're going to have a very strong base as well. Acids, they start with a hydrogen positive ion. A hydrogen atom is simply just a proton when it loses that electron and becomes positive. We talked about EPNA in previous videos. Watch my previous videos to know a little bit more about EPNA, the atomic structure video. I believe that's like video number 3 or 4, something like that. And here are the types of acids that we talked about just a few seconds ago. Monoprotic acid, an example would be HCl. Why is this monoprotic? Because it has 1 hydrogen proton. If it has 1 proton, it's monoprotic. If it has 2 protons, it's diprotic. And if it has 3 protons, it's triprotic. Okay. Now for indicators, you can look at table M. So here we are, table M. Table M shows you the approximate pH for color change. So for example, methyl orange is going to be red. If the pH is of the solution or acid or the base, whatever you have, if the pH is between 0 and 3.1, you're going to have a red color. If the pH is between 4.4 and 14, you're going to have a yellow color. So same thing here. Let's say for litmus paper, if the pH is between 8.3 and 14, you're going to have a blue color. If the pH is between 4.5 and 0, you're going to have a red color. 4.5 to 0. Okay, so depending on what the solution is. So let's say, for example, you have a solution that has a pH, and you're trying to identify the pH of that solution. So you put that solution and you put different indicators in that solution. Let's say you put methyl orange in that solution, and you realize that methyl orange turned yellow. And then you take a small sample of that solution as well, put it in a different container, and you dip a litmus paper in there. And you realize that your litmus paper turned red. And now you're being asked, what is the pH of that solution? Well, if methyl orange turned yellow, then the pH of that solution is above 4.4. If the litmus paper turned red, then the pH of that solution is less than 4.5. So now we know we're greater than 4.4 and we're less than 4.5. So the range of the pH in this case is going to be 4.4 to 4.5. That's going to be the pH of that solution. Okay. Going back to here to see if we missed anything. Nope. So that's pretty much it about acids and bases. Let's go back to the questions. Read those questions carefully, or read those statements carefully and determine whether they're true or false. Take your time and answer all the questions.